Hi guys, so we are continuing the B module and today we are doing chapter B3, which is basically rate and work. So let's explore what is rate and work. Now it has two parts to it. First is obviously the normal your standard rate and work problems, and the second part, a small bit, is basically pipes and systems. So let's explore rate and work first. There is a formula for work done that you should be aware about. So work done is defined as number of people slash machines which are working and how many hours per day they are working into number of days that they are working. So this is the formula for work done. Now obviously how many hours per day that they are working can also be called as at what rate these guys are working. So if the workers are working for 6 hours per day or 8 hours per day, or the machines are working for 10 hours per day, and so on. The number of days taken to finish the job can also be called as time taken to finish the job. And with these two new things added, the refined version of the formula becomes number of people slash machines into rate into time. So this is the simple formula for work done, based on which this entire chapter revolves around. Then, since we have seen the formula, let's very quickly see some relations also as far as this is concerned. The first one of them is rate is inversely proportional to time, provided number of people and machines is constant and work done is also constant. And this makes a lot of sense because if you remember, the way that we had defined the rate is that how many hours per day the workers are working, whether they are working for 6 hours or 8 hours or 10 hours. Now think of this, if the workers start working more number of hours, obviously job gets done earlier. That means if I increase the rate, time taken is less, and hence they are inversely proportional. And vice versa is true. If I slow down the workers, if they if they work only for less number of hours, obviously the time taken to finish the job will increase. The job will get delayed. The second relation is also that number of people and machines is also inversely proportional to time, provided rate and work done is constant. Now this also makes a lot of sense. Suppose 10 workers are working earlier, and if I make sure that now instead of 10, 15 workers are working, obviously the job will get done earlier. That means time taken is reduced. So if I increase the number of people, time taken is reduced. So that is also inversely proportional. Now, based on these two relations, let's explore some ratios. So first is rate of two people is in the ratio A is to B, then time taken by the two of them to complete a piece of work will be in what ratio? So we know that rate and time are inversely proportional. So if rate is in the ratio A is to B, time taken is in the inverse ratio, which is B is to A. Then work done by the two of them in the same time will be in what ratio? Obviously rate and work done का relationship figure out करना पड़ेगा. Rate is how many hours per day the workers are working. If they start working for more number of hours per day, obviously more job is done. If they start working less number of hours per day, less job is done. So that gives us an idea that rate and work done are directly proportional. So if rate का ratio is A is to B, work done ka ratio should also be A is to B only. Then next part is the way that we define efficiency. So efficiency is defined as work done per unit time. Then there are a couple of ways to define efficiency. So for example, the first one of them is something like this statement which says if A is twice as good as workman as B. So if you want to explain this particular statement to a layman, how you can explain the statement is that A is twice as good as workman as B is, in simple words, जितना भी B काम करता है A उससे डबल काम करता है. And with that being said, ratio of work done by A and B in the same time, दोनों का work done का ratio हो जाएगा 2:1. Why 2:1? Because हमें ये पता है कि जितना भी B काम करता है A उससे डबल काम करता है. So that is the interpretation of this particular statement. Work done का ratio आ गया. The second part is time taken का ratio. So obviously work done and time taken are inversely proportional. So अगर work done का ratio 2:1 है, time taken का ratio will be 1:2. So this is one way of defining the efficiency. Now what else that they can change up here is that instead of saying twice as good, they might say A is 1/3 as good as workman as B, and A is 6 times as good as workman as B, and so on. So all you should be able to do is just figure out the ratio of work done by that from that statement, and then eventually whatever is the ratio of work done, you take inverse of that and you get ratio of time taken. This is one way of defining the efficiency. The other way of defining the efficiency can be in terms of percentage, which is something of this sorts. It says if A is 20% more efficient than B. So how do we analyze that is A is 20% more efficient than B. Here we are going to use method of parts. 20% 1/5 more, yani we come to know that it's a percentage increase that these guys are talking about. So 1/5 more यानी जितना भी B ने किया है A ने उससे एक ज़्यादा किया है. So method of parts use करके what we can say that B is 5, which is the base, which is the denominator of the fraction of 1/5, 20% का, and that means जितना भी B ने किया है A ने उससे एक ज़्यादा किया है. So B ने अगर 5 किया है, A ने उससे ज़्यादा एक यानी A ने 6 पार्ट्स काम किया है. So that tells us कि वर्क डन का रेशियो A और B का होना चाहिए 6:5. How you arrive at this 6:5 is something which is very very important, which we have been exploring since the first topic, which is percentages. Similarly, work done का रेशियो 6:5, time का रेशियो inverse of that, which will be 5:6. And this is another broader application of percentages which you can apply here in terms of analyzing these kinds of statements. Again, what else that they may switch it up is, one is the value of percentage, and for that matter obviously you would require to know the fractions. So one more reason for you guys to study the fractions and the percentage equivalents very effectively. The second part is, instead of more they may say less or something of that sort again, and now based on that you should be able to figure out the ratio of work done by using method of parts or method of fraction, whichever is convenient to you. Once you get work done ka ratio, take inverse of that and you get time taken ka ratio. The next part is a small note as far as the payments are concerned, which is the daily wages. So the wages are distributed in the ratio of the work done and should be never distributed in the ratio of the time taken to finish the job. Obviously this makes a lot of logical sense also, because if you start paying the workers based on how much time they are taking to finish the job, obviously they will never finish the job. So we should never pay them based on the time taken, but we should always pay them based on how much work they are doing. And this note will help us to simplify some word problems wherein which they talk about the payments and the distribution of the payments and how much share that one of the workers should have and all. So whenever the distribution comes up later on while solving the questions, we are supposed to figure out कि उनका वर्क डन का रेशियो क्या है, and in that ratio we will be dividing the amounts. The next part is actually solving of the problems. So the question is very simple. Let's see that first. A can paint a wall in 8 hours working alone. B can also paint the same wall in 8 hours working alone. If both of them decide to paint the wall together, in how many hours it should be, they will be able to do so. Very simple, straightforward question. A alone paints the entire wall in 8 hours. B alone also paints the entire wall in 8 hours. And if they both start working together, obviously they both can do the same job in same time. That tells us that their efficiency is constant. So their efficiency is constant. If both of them start working together, obviously both will finish the respective half of the wall in 4 hours. So in 4 hours, the entire wall gets painted. It's a very, very simple warm-up question to start with the idea, but the real deal is coming up in the next question. So the question is, A can paint a wall in 8 hours working alone. We can also paint the same wall in 6 hours working alone. If both of them decide to paint the wall together, in how many hours they will be able to do so. Now this is where it gets interesting, and this is where we will follow a very unique and a different approach called as a LCM approach. Now please don't add these numbers of 8 and 6 hours and take the average, because that will give us the 7 hours as the answer, which is fundamentally wrong. Why it is wrong? Because we alone can do it in 6 hours. So if together they do it, it should definitely take less than 6 hours. So 7 hours can never be the answer. So what do we do here is we obviously look at in a very different perspective. So for example, both A and B, whatever time that they are taking, but they are painting the same wall, that means the work done has to be constant. And because of this constant, let's assume the work done to be LCM of both 8 and 6, and 8 and 6 ka LCM is 24. So let's assume that they both have to do 24 units of work. Once you assume the work done as the LCM, what else you do later is find out the individual efficiency. So to complete 24 units, A takes 8 hours. That means his individual efficiency is unit per hour. Similarly, B also takes 6 hours to finish the 24 units of the work. That means B's efficiency is 4 unit per hour. So A's efficiency 3 unit per hour, B's efficiency 4 unit per hour. They said that they start working together. So if they start working together, the combined efficiency of both of them becomes 7 units per hour. And at that combined efficiency of 7 unit per hour, they are supposed to finish 24 units of the work, which is the entire work of the wall. And that time taken is given by a formula. Work supposed to be done divided by the efficiency. In this case, it is combined efficiency of A and B, which is 7. So time taken is 24 by 7 hours. Now one more unique thing that you will probably find in this topic is that the answers will always be, or most of the times will be, in case of mixed fractions. So you probably will not have 24 by 7 straightforward. You'll have to divide and convert it to a mixed fraction. And after doing that, you get the answer as 3 by 7 hours. So the time taken by both of them to complete the job is 3 by 7 hours. And this is how we try and solve the maximum of the problems of rate and work using this particular LCM approach. So this was the first part of the topic, which is rate and work. The second part is pipes and cisterns, and this is also very similar to rate and work, but immediately let's first do something, the same part that we explored earlier, which is the ratio. So here they are talking about the ratio of the radius of the two taps A and B, which is in the ratio 1:2, and then they are asking us to figure out two different ratios. One is the output from both the taps, and one is time taken by both the taps. So output यानी how much water is coming out of that tap, and usually radius दिया है, so assuming tap is of a circular shape. Output from the tap, in simple words, area of circle. We would know the formula, which is pi r square. One of the radius is 1. If I do pi r square, 1 ka square 1, I get just pi. And the other has a radius of 2, so pi r square, I get 4 pi. And when I take the ratio, pi gets cancelled, and I get the output ka ratio as 1:4. This is the exact reason why the ratio is 1:4. Tap circular shape, इसीलिए square कर रहे, because we have been given ratio of the radius. Output यानी work done का ratio 1:4, time taken का ratio inverse of that, which is 4:1. So this is the small thing as far as pipes and cistern is concerned. Another important point as far as question solving is concerned is that pipes and cisterns is very similar to rate and work, and there is an additional concept called as a leak pipe or a drain pipe or something of that sort. So leak pipe ideally will empty the tank or will drain the tank, and the rest of the taps will try to fill the tank. So obviously filling the tank is supposed to be the positive work, emptying or draining the tank is supposed to be the negative work. So whatever numbers and calculations which are associated with the leak pipe or the drain pipe, you are supposed to take them as negative. So just attach a negative sign and you will not face any problems as far as the problem solving of pipes and systems is concerned. So that's it, folks. As far as this particular idea is concerned, it's a very simple topic and very straightforward topic, but the question types will also tell you some or the other couple of new things as far as learning is concerned. So thank you so much. If you have any questions and queries, do let us know.